Welcome to the lair of the Batty Boffin.
Hi Batty fans, time for a little more multiplying with the Batty Boffin. In this video we're going to be looking at how to multiply when you've got decimals in there. But before we get on to that, I just want to do a little bit of revision with normal multiplying when you haven't got decimals. So here we've got 472 times by 564, quite a big multiply. And I'd like you to just multiply those together, please, to make sure you remember how to do them. Either use this compact method, the traditional long multiplication, or if you're not sure how to use that, you can use the grid method. There are videos on how to do both of these earlier on. Compact method here is better. It's smaller, it's quicker, and it's much less prone to errors. Grid method does tend to have a few errors in it when you get into big numbers here. So if you can possibly use compact method, do that. And if you're not sure how, check out some of the early videos that do. Okay, so time for you to pause the video and have a go at doing this multiply by whichever method you prefer. Right, let's just nip through those. Okay, for the traditional compact method here, we'll just nip through this very quickly here. I'm not going to spend ages explaining this. Okay, we're doing 2 times everything. 2 4s are 8, 2 6s are 12, 2 5s are 10 plus that 1, 11, 1 1 2 8. And then 70 times everything. 7 times 4 is 28, 7 times 6, that's 42, 43, 44. And 7 times 5 is 35, 36, 37, 38, 39. And then 400 times everything. 4 times 4 is 16. 4 times 6 is 24 plus that 1, 25. And 4 times 5 is 20 plus those 22. So adding those up we get an 8, 10, 1 and 4 and 6, that's 11 plus that one there, 12. 1 and 9 is 10 plus 5 plus 1, that's 16. 1, 2, 3 is 6. Okay, I get 266,208. I hope that's what you got. If you didn't, well, either you're wrong or I'm wrong. We better check it. Let's see if we get the same over here. So this is exactly the same sum done by the grid method. I think I'll use blue for this one here. Okay, for 400 times 500, remember we miss off the noughts. We do 4 times 5 is 20. And then we add 2 more noughts there because it wasn't actually 5, it was 500. And 2 more noughts there. 1, 2, 3, 4. And then we do 400 times 60. 4 times 6 is 24 plus 3 extra noughts. And 4 times 4 is 16 plus 2 extra noughts. Okay, 500 times 70, 5 7s are 35, plus 3 extra noughts. 6 times 7 is 42, plus 2 extra noughts. 4 times 7 is 28, plus 1 extra nought. 500 times 2, well we know that one, that's 1,000. 60 times 2, 120, and 4 times 2 is 8. And then we've got to add all this lot up. Okay, I'm going to speed up the video while I do this, I think. Phew, 266,208. So we've got the same answer there. So that means that our sum comes to 266,208. But what if it were not 472, but 4.72? And what if it were not 564, but let's say 56.4? There was a decimal in it. What would be the answer then? Well, the digits are going to be exactly the same. When you multiply a 4 by a 6, you're always going to get a 24. And if it's a 40 by a 60, it's still a 24. You just got some extra noughts in it. And it works the same with decimals as well. So whenever you're doing any multiplies with decimals, what you can do is just throw away all the decimal points and do the multiply like it's normal numbers and get all your numbers here. So these digits are correct. They just need a decimal point in. And there are 2 ways of doing it. One is, handy little trick, the number of decimal places in the question is the same as the number of decimal places in the answer. 1, 2, 3. 3 decimal places in the question. 1, 2, 3. 3 in the answer. The other way of doing it, which I particularly like because it works for multiplying and dividing as well, and all these kinds of things, is to estimate. We do a very vague estimate. I'm going to call that 5. 4.72, it's nearly 5. That I'm going to call 50. I know it's actually closer to 60. We could say 60 if you want, it doesn't matter, 50 or 60 or both do. And then we say, what's 5 times 50? Well, 5 times 50 is 250. If we'd done 5 times 60, it would have come out as 300. So we need an answer that's somewhere round about 250. So clearly the decimal point has got to come here, 266. 2.6, that's nowhere near 250. 26.6, that's nowhere near 250. 266, yep, that's near 250. 2,662, no, that's way too big. It'll always be really obvious where the decimal point's got to go. So what we did there, we just did a very basic estimate there. Call it 5. You call it the nearest easy number. And we called that one 50, or we could have called it 60. Which means we need an answer somewhere near 250 or somewhere near 300. Clearly, that's where the decimal point's got to go. So, I'm just going to wipe down the rest of the board here, and then I'm going to have some for you to have a go at. See you in a minute. Right, here we go with these. I've got 3 rather dastardly looking sums here, all with decimal points in. And you need to do those multiplying by either grid method or compact method, whatever you like. No calculator, please. And if you just ignore all the decimals, so pretend that's 492 times by 348, just ignore the decimals. Get the answer here and then put the decimal in, either by counting the decimal places in the question, same as the decimal places in the answer, or by estimating, whichever you prefer. Okay, I'll see you in a minute with the answers. Right, how did you get on with those? Okay, here are the answers you should have had without decimal points. So these are just the figures. For the first one, 171216. For the second one, 427716. And with a big one at the end, 3897343. I hope you got those. If you didn't get the same digits as these, then go back, check your working, but don't worry about it because we can still put the decimal points in the right places. So looking at the first one up here, I'm going to do these by estimating because frankly counting to 3 is not exactly difficult and I'm sure you can do it. So for this one here, I'm going to call that one 50 and I'm going to call that one 4. I could call it 3, doesn't really much matter. 50 times 4 is 200. If I'd done 50 times 3, it would have come out of 150. It really doesn't matter. So we need a number that's somewhere around about the 200 size. Decimal point goes there. Second one, I'm going to call that one 10. Anybody who's done physics amongst you might recognise that as the value of g, acceleration due to gravity. And that one there I'm going to call 4. So obviously we need an answer somewhere in the region of 40. It'll be there. And for the last one, what shall I call that one? 600, I think. And I'm going to call that one 6. I know it's closer to 7, but that's because 6 times 6 is dead easy. 6 sixes are 36, with a couple of extra noughts on the end. So I need something that's about that size. There it is. And as we can see, 1, 2, 3 decimals in the question, 1, 2, 3 in the answer. So I hope you got all those. Quite a lot of multiplying there, a lot of brain work, so well done for that. Pop back to the next video where we're going to have a look at a bit of this kind of putting decimal points in where the numbers aren't maybe quite so familiar, maybe some naught points and weird stuff like that. See you next time.
Mwahaha! Mwahaha! Mwahaha!